Hey everyone, welcome back to Native GIS Today.
Hey, welcome back to Native JS again. So today we are back with again Python related projects which we create on Native JS series, right? So we are back, and for now, from now onwards, what I'm thinking, like, you have been subscribing to our channel a lot, means daily some viewers are viewing the channel and they are subscribing as well. So I want, uh, if you can subscribe and you can create 3000 subscribers on our channel, then I'll be publishing the next one. So for now we'll be continuing with this project. So what my aim is on this Native GIS is, we'll be creating GIS videos, Geo AI related videos, what are going on in the industries. So we'll be coming off with new ideas, but for now, this Python related and for Geo AI related projects. So what we'll be doing is, I'll be doing some of the videos live, and I'll be recording some of the videos. Like, for now, this video has been recorded, and I'll be publishing the whole raw video of how I am doing the project, how it is being done, and that live coding and everything I'll be doing, how we are solving it. That thing will be doing in this particular video. But I'll also add a summarized part of this video. Let's say it can be 10 minute to 12 minute, or maybe 15 minutes, depend upon the video content. I'll be publishing that as a summarized video. For this as well, I'll be providing that video, but for now this video might take around, let's say, 1 hour, 2 hour, 3 hours, I don't know. We are starting this video, this particular project. So we'll be doing, let's say, small 15 to 16 projects in this type of series, and we'll be developing our Python skills, we'll be developing our GIS skills, we'll be knowing what we are doing, and let's say we are creating a portfolio. Okay. And as well, what I will be doing is, I'll be uploading this project files and project description, why we are doing it, why it is there on a portfolio, and we will be adding that in the GitHub, and I'll add that GitHub link in the summarized video when I'll be publishing that. And after that, you can check it out, you can also do those projects at your end, and you can also learn, like, okay, how these things has been done. Okay. So mainly, our goal will be, let's learn together and let's find it out, like, how it is being done. uh, so basically, welcome to Native JS again, guys. So you know how we are doing. We are continuously producing videos, and we are on a production size of very less, but yeah, I'm doing it from my own. And I require your help, and if you can help me, so please subscribe to the channel and like my videos. That will be only one help which I require. And please, if you provide some good comments on our videos, that will also be a great thing. And okay, now let's begin with our project. So I think the gist of this particular thing is, we'll be developing the projects, we'll be developing our content on a different scale now. So what I believe, let's go and start this uh, project work. Okay. So now the project which we are going to do is on population density mapping, gridded. So mainly you can say that this is a full project or an enhanced version of, there are a lot of population density mapping which are being done from, you can get from the YouTube as well. But okay, let's try it out from our end, how we'll be doing it. If you are fine, okay, with this project, then you can check for the further thing, and you can see like how it is being going, and you can find it out. Okay. So for now, let's say, uh, what we'll be doing is, we'll the task which we will be doing on this is create a fishnet grid, overlay population raster, and then summarize the population per grid cell. Okay, so this will be the our task on this particular project which we will be doing. So data will be, let's say we can take the world population data, or we can take some other data as well, whatever you want. Skills will be zonal statistics, grid creation. These are the skills which will be we require on this thing. Tools will be raster stats, geopandas, rasterio, matplotlib, and folium. Okay, so what I'm thinking is, let's say we can start with the project understanding and how we are framing it. We can understand that. Okay, so what we are doing, we take a population raster. Each pixel is equal to the number, some number of peoples. We create a grid, let's say fishnet, and calculate how many people fall in each grid cell. This gives us a spatially uniform population density map. Now this is what we will be doing in this particular project. Okay, so why this matter? Okay, population density grids helps with let's say various things. One will be urban planning, let's say schools, hospitals, roads, disaster risk planning, let's say evacuation zones. So you can say that I'm from India and I'm from Odisha as well, and I know that in Odisha a lot of cyclones are being there. Means they hit in each, I say two cyclones hit per year. So there should be data which we should know, like how much population needs evacuation zones, or what evacuation zones need to be created. So all those things need to be there. Another thing will be, let's say market analysis, like the store locations. uh, there are other characteristics, let's say, or other, or what I can say, significance of this thing will be on the telecom industries, on utilities industries, tower placement, so they can see all this population density grids, and they can build out their projects. Okay, now the GIS concepts which are involved is, one will be, here we will be discussing about raster metadata, the resolution, CRS, extent, all those things. Fishnet grid extension or fishnet grid creation, raster vector interaction, zonal statistics, and chloropath mapping. Okay, so I actually why I am why what I was doing is, I have noted down some of points on my list, and some of them are I am remembering as well. Okay, so that's why I might fumble a bit, but yeah, this is my first creational video like this, so please support me. Okay, so now the thing will be, what the final output will be like. Let's say will be the final output which will be achieving, that might be a grid layer with population per cell, chlorophyll maps, static plus interactive, summary stats will be there, like 10 high density cells where the population is more, where the population density is more, so that will be there. Okay, so now let's say, uh, as I am also thinking about, let's create, or let's assume like we are a project manager, right? All those project managers who are seeing this video might get a chance, or they can think like, okay, what we are doing. So that's why I also created this project in a bit of project structure or architecture, what all things. So we'll discuss them as well, so that it could help others to get to know like how the project management is going, how the project structure is created, what is the architecture is been created. If you want to work on a small projects, so we can discuss them as well. Okay, so So the project structure and the architecture will be like, let's say, first we'll be developing this on Google Colab notebook. Okay, so I have a pro version of Google, which I have taken on a particular Gmail account. On there I get some space, and as well as some, let's say, you will get a good quality of running space where you can run the code on the Google Colab notebook. There are free versions as well. I have not tried it, but you can try it at your end, and you can tell me in this video or in the summarized video when I'll be publishing that what are the challenges you are facing when you run this code on the Google Colab free version. Okay, so try it out and let's see, like, let's learn together. And yeah, now getting back into the Google Colab notebook structure, first will be the project title, overview, introduction, and our problem statement, which we have already discussed. What are the data sources, install and import of the libraries, what are the libraries that will be importing or installing in this. Then load the population raster. Sixth will be load and create AOI, area of interest. Reproject the area of interest into for a grid creation. Okay, then create fishnet grid. Reproject grid back to raster CRS. Then run zonal statistics. Then compute area and density. Then after that, visualize population grid map. Interactive map will be the optional one. Then the summary and insights, limitations, and the next steps. Okay, so these are, let's say, I have divided this whole thing into 15 points. So if you want, I'll recollect them once again. So the Google Colab notebook structure are: first will be project title and overview. Second will be introduction and problem statement. Third will be data sources. Fourth will be install and import libraries. Fifth will be load population raster. Sixth will be load the area of interest, or we will be creating our area of interest. Then we'll be reprojecting that area of interest as per grid creation. Then we'll create a fishnet grid. Then we'll be reproject grid back to the raster CRS. That's the ninth one. Then the 10th one will be run zonal statistics. 11th one will be compute area and density. Then 12th one will be visualize population grid map. 13th will be interactive map. We can create an interactive map. That will be optional thing, but we can create it. 14th will be summary and insights. 15th will be limitation and next step. So this is a project structure which we can create for this project. Okay, now what I'll be doing is, when we will complete this project, I'll populate this particular code, or let's say what we have developed. I'll add it into the GitHub repository, and I'll share that link as well, where you can go and you can check the structure as well. You can see why we are doing it, what is the significance of what we are doing. So all these things of this particular project will be available in the GitHub, so that it will also be created as a portfolio for me, and as well as you can download it and you can create for your area of interest. You can create or any other things, the next steps or the next steps which can be done on this particular project. Let's say you will be analyzing a market analysis, and you can see that where the store locations will be there. You can use this project, or let's say whatever particular which we have discussed, like what are the significance of this project, where it will be used, like urban planning, disaster risk, market analysis, telecoms, and utilities. So on those next steps you can utilize this after learning this. Okay, so now let's start with the project, and let's see why we are doing it, what is the significance of it, and let's build it. Okay, so guys, now what we'll be doing is we'll be uploading the raster file which we have downloaded to our Colab environment, and then after that we'll be installing the libraries, then the set of directories, then load the raster into that, and then after that we'll be doing it. Okay, so before any special analysis, we need the raster files, so geotiff available in which we need to be get it available in the Colab environment, since the Colab resets the environment each time. Uploading the file manually will ensure that it will be available for reading and processing it. Okay, so basically how what from where we will get this uh, thing is, so let's say we can do one thing will be like we can go to world population data, and from there we can get the things, and another one will be, let's say, we can get it from the gridded population of world. From there as well we can get it. So let's say I'll just show you like how we'll be getting it. So this will be world population data catalog, and then inside that there is a data thing is there. So inside data you will be clicking it, there will be this population count. So click on population count, go to individual countries, and in individual countries, right, as I'll be doing for India. So in India from 2015 is that, so you can go and download the, you will click on it and it will get downloaded. Okay, so I have already done it, so I'll be not doing, and it would might be taking you, let's say, some 30 minutes of time, because the speed depends, and I have a good speed, but still it took around what I'll say, uh, it took around 30 minutes I guess. So yeah, so what we can do is we can work after that. Okay, so now let's uh, add that. So here the resolution will be mainly 100-meter or 1 kilometer. The CRS projection system is basically EPSG 4326. Okay, so what we'll be doing is we'll be uploading the raster to the Colab. Okay, so let's write it like upload the raster to Colab environment. Okay, so let's import OS, then from Google Colab import files, import raster view, and then the step one will be create a folder that will be content slash data. Okay, and so already I have created the steps, so I am not writing again. Where we need to be writing, we'll be writing it. Okay, so then to upload the raster to the system. Okay, so let's run it. Might be it gave some error, I don't know. Okay, to some raster so folder raster model is not found. Okay, so let's see why. I think we need to install the raster view. Okay, let it install there. Great. Okay, it installed it, successfully installed, and run. Now it is giving please upload your world population tile 5. So choose files, I'll choose this is the one, is uploading. Let's okay, it might take time. Till then, what the other things will be, whatever will be doing. So it is giving a less time, 1% is done, so it is slow. So for now, let's I'll be back when it is done, when the upload is done, or it will be at 99%. I'll be starting again. Okay. Hi guys, back again. But yeah, the thing is, I thought of like let's it was taking very much time, very time. So what I did is I canceled that. I thought of doing another way. It was 11% done, and then after that I canceled it. So I thought of, let's go through our drive method. Let's upload that into the drive, and then after that do the file thing. So I'll be writing again, like let's from this drive. Path to So wherever you have kept the file, right, you need to write this, and then the path where you have kept it. So this is the Indian file, that particular TIFF file which I have uploaded. So you need to be put that particular path over after that. Okay, guys. So let's see if this works. Okay. So guys, what you need to do is, after providing that content drive, it will be running it and it will be accessing, or it will ask for the drive path. So the drive path should be in that same folder, and after that you need to give the access over that, and after giving all the access, it will work. If you give only one access, it will not work. I have tried it, and that's why I'm saying that you need to provide all the access, and then after that it will work. So it is saying that now it has been added the mount. Okay. Now when we're focusing on the next stage of what we need to be doing it. Okay. So our raster will be on this particular part. Alright guys. So let's start. So now let's start with the coding part. We have uploaded the data now, and now let's start the coding part. Okay. So let's add a code. So here what we'll be doing is, first we'll be installing and importing the libraries. So for that, what we'll be doing, we'll be install the tools that will help us in this particular project. One will be for the vector data, it will be GeoMinus. For raster data, it will be Rasterio. For journal stats, it will be raster stats, and for maps, it is matplotlib or Foolean. Okay. So let's start importing the live. So first, before import, let's install as well. राष्ट्रीय folio and context. Okay, and then geopandas import as. Okay, it is giving directly because I think I have already worked on it. Raster stats. Okay, let's do it after installing. It will take the things. It is not taking. Let's see why. Why? Context as CTS. It is doing my own man. Nice. Oops, it is there. NumPy. Import as. Yeah, we have already done that. So basically, we are installing GeoPandas that will be helping us to handle shapes like polygons, grid, and all. Rasterio, we are importing it to give the raster images. Raster stats we are using for to run the journal stats, okay, journal statistics, or to run the journal statistics. Yeah, basically for that. Matplotlib draws map, the map function which will be using. For Folium, it will make maps interactive. For Shapely, helps create great polygons. So let's run this as well. Let's see what's the error. Uh, Journal starts. I think. Okay. Importing libraries. No model name journal starts means Python cannot find it. This is because journal starts is a function within the raster starts library, not a standalone connection. Okay, accept that. And let's see. import generations. Okay, we have written it all up. Box sentence. Okay, externals. Important is done. Now the step two will be set the paths and folders. Okay, let's go. So we set paths and folders. Folder slash content. Yep. Then data underscore dir data directory will be output will be quest maybe data.log. Okay, okay. Data.being not exist is equal to okay. Okay, maybe output dir output. Okay, output is okay. Output we should have. That's why I think it must output DS. Okay, so this is there. Then we have tables again. We have tables. That is so Yes. Sorry. What I'm doing. Sorry. Yep. Wow, it is. No, it's learning and it is giving as well, right? Nice. Good. Um, okay. Last. But raster is not defined yet. So what we can do is, I think we have defined the raster area, right? Oh, okay. So let's run this. Okay. Already. So here what we did is basically we set the paths and create directories. Make the IRS will be like it will create a directory. Okay, and after that we see that we printed the directories over here. Okay, so yeah, so we have laid down the laid to the foundation of the project, and let's now create to the creation of this particular project. Okay, so now let's load and inspect the world population rasters which we have downloaded. We need to see the data like on which projection system it is there, and as we already know like it is there, so we can work on that as well. Okay, so the next setup will be, so why we are doing this thing will be like we need to know the CRS is system. Okay, the other one will be the resolutions and resolution. So what will be this control the grid size and the projections. So what will do this the code is CRS resolution. This is statement is taken by its own. I have not written how it is taken. I don't. So, but that has been calculated good. So the next one will be the green. There will be lot. Okay, so this thing is figure. Let's take 6 by 6. Okay, so whatever the result will take. Show source. So this I have consumed this thing from lot better title. Raster. Mhm. Okay, so I guess I have added all the things for this thing. So we'll be seeing the raw population layer that will convert into a grid-based population density map. Okay, let's try that. Yes. Okay, we got lot of errors. Let's figure it out. Error. Directly daily handling another exception occurred. Okay, there is error. No such file directory means the error cannot be tipped. Please double check the file exists in drive. After exactly this location is dirty. But it is there. I don't know why it is not getting it. Content drive, my drive, I think it's no. I'm going to do a Python project. Data and this thing. Oh, it is not going. Okay, let me try to fix this thing and then we'll do that. So guys, what I did is I checked again, okay, in the drive, my drive, and where I have kept it. I checked this thing, and after that, I tried to run this thing if the raster is present or not. So basically, you can see that if was the path of raster, we just I again modified it, uh, the path. So here the thing is, I think some content CE space is there, so that should be changed, and something it got off, so that's why I think I need to again paste it, run it, and then after that rerun this thing, and then I got the raster file just at that particular location. Okay, now let's rerun this thing, and then let's see if what it will run. Okay, again we got the USPG as 4326. Okay, the resolution is this, bounds we got, but after that, block figure, dataset data, no attribute page, attribute, explain the errors. Let's see like what is the errors. Given dataset only with no attribute weights means your range of the way and so width or height. Okay, I think I have to replace that as a pointer. Okay, we got the things at our end. So that should be small w and small h. Okay, so yes, the things which we have forward because we are going with the autocorrect thing, so that's why that will be. So it will now plot the graph. So let's see how much execution time it will take. 35 seconds, 37 seconds. Let's see. It might take last time. Okay, because last extent whole India extent part is being covered already. Okay, let's see. So guys, after thinking and after checking all those things, I got to know like the name which we have provided over here was read this, but it should be VIRIDIS. So let's I did it again. In between that, I got a crash actually in the RAM which I am using. I don't know why it is failing, but after that now it is again running. I need to rerun all the things, and then after that it is running right now. See, the session has crashed. Restarting. Okay, now it will give error. I guess. Yep, I know that. Okay, no worries. Let's run again. Selective. I think it is thing. State. Rerun it. Installing again. Everything need to done again, man. So this is very difficult. I don't know why it is not getting connected. Otherwise, I'll see like why it is getting crashed. Okay. So okay, I paths are done. What I'll do, I delete this thing. I'll see like if the thing is done. Okay. After interest, it is again returning some. Then let's try to rerun it again. Why it is getting filled? Let me research something. It again crashed. Okay, let me do the research again, and let's see like how much time it will take. We'll be back. So guys, now there is a another explanation which we need to be I need to be doing is, so this will be happening. Okay, it might be a 3 hour as well. So the thing is, now as the TIFF which we are using, it is a large TIFF of India, right? So it couldn't able to show that whole thing in this particular raster which we are plotting it out, right? So what we can do is, we'll just read the metadata of it. We'll try to get a AOI of any region in of Delhi or Indrapuram area or something like that, where the density is heavy, and we'll see a 10 by 10 kilometer AOI, and we can see that. We can take Bangalore as well. All those you can get the coordinates, and we'll see like how we are doing it. But yes, the main thing is that if you'll see that the GPU thing. So if you have a large GPU, then you can able to or CPU, you can change the environment. But basically for raster processing, you can take the CPU thing, which I have taken. It's a Mac Mini system, and 16 GB of RAM, and so I think why, I don't know why it is taking so much load on it. But yeah, I think if you have a heavy system, you can see this particular code and you can check it out. But if it is not, then you can just plot it, which we'll be writing in the next part of it. So we'll start with the phrase, and we'll see like how it is going. So this is the benefit of this thing. We are learning on this thing as well, like what are the things which can be done. So this is, you can say, as a project, as in a project you are learning bit by bit. So the viewers who are seeing till this time, it is like, I think I'm saluting you. So it will be a long video, but yeah, if you will be with me on this whole video, so I think you will be learning a lot of things which I am as well facing, and which you guys will be as well facing it at your end. So by learning this, you are also learning like how to debug the things and how to easily solve those things, right? Yeah. So what I guess, we'll start it phrase, and we'll start it like how that need to be done. So I'll be back in a minute. Give me it, the I'm pausing it over here, but now I'll start it again. So the video will be continuing. Okay, so in between that I'm taking some pauses, so that's why I'm pausing the video at my end. But in when you will be seeing the video, it will be starting after that. Okay, so back in a minute. So guys, we're back, and let's start again because it has crashed. So this will be running it again. Okay, this is done. We need to install it again, install the libraries. Okay, and I have also added some text over here. We need these tools, so let's import all this. Done. Then the same directories which we have discussed already, I'm running that thing. So it is also done. Raster is there. Now why we are doing is what is the next step which we will be doing is we need to finding out the CRS coordinate system or the projection resolutions, bounds, width and height. This controls our grid size and AOI alignment. Okay, so here before we are doing this thing, but now what we will do is we can let's raster dot open raster source let to just print this much thing, nothing else. Okay, raster open, then print CRS source xy, resolution will be the x comma y, the other one will be print. So keep the indentation properly. Okay, let's see, like, so we got that raster is opened, CRS, the projection system is EPSG 4326. Okay, and after that the resolution is this, the 0.0083, bounding boxes this one, which will be India's bounding box. So width will be width and height is this. Okay, so here from here we get to know regarding the CRS that will be working on, how detailed the raster is, whether your AOI which will be choosing, let's say we'll be choosing Indrapuram, Indrapuram which falls inside this bounding box or not. Now we'll be defining our Indrapuram AOI. Okay, defining the AOI. So now the code will be, so as we don't want to process the whole thing or whole part of India, we only care about, like, let's say we can process it, but my CPU is not providing that in this Google Colab. Whenever we'll be working on, so let's say it is a small project, right? We can check on the on a particular AOI and we can check on it, right? You can choose a whole India and you can do that. So you need a larger specs of system where you can work on it. Let's say you can take that from any particular environment and you can use that, let's say cloud or something, you can work on it, right? Yeah, so let's start with uh, AOI box. So what I'm choosing is, so mean x and y and mean x and y of, means left or bottom and the right and top. That xy I have taken, it's uh, from the internet as well. And then after that what I do is AOI equal to dot geo data frame in that ID. One, CRS we have, that is, so this one will be taking stick to develop on is, I don't know why it is taking so. Okay, so then, okay, so what we'll do is box min x min y max x max y. It's a rectangular polygon over Indrapuram area stored in a geodata frame with the CRS, that projection system EPSG, which we already have, same as the world population data. So you have a precise study area polygon over Indrapuram, where everything else like grid clipping stats will be done. One only inside that rectangle. Okay. So let's run this. Okay, we got the area. Now what we'll do is clip the area, clip that raster with this particular area. So I'm writing like what I'm doing because I have already prepared that thing at my end. So I am also saying that thing and I'm copy pasting it. Okay, so don't think like I'm doing something else. So just for your sake, um, just checking, and because so that I shouldn't give you any misinformation, that's why I'm doing it. Okay. Yeah. So clip the world population raster to Indrapuram AOI. You can choose any place of yours as well as you can choose, because I have previously stayed back over this particular place and I got to know that okay, it might have it has the population of that particular level. So I am thinking like let's do it. Okay, so reduces the raster size. Why we are doing this particular thing clipping is it will be reducing the raster size, speeds up the processing, I guess, prevents cola from crashing, focuses analysis on the actual area of interest. This is not my actual area of interest. I want to do for the India, but yeah, what I can do, no worries. Support me guys, I want to buy a new PC for me. Okay, no worries. Let's add the code area now. So, okay, from so the code which will be rasterio.mask, which is basically crops the raster to that particular AOI polygon, where we'll also be updating the metadata. Okay. So So clip raster, we are basically defining a new output raster name for the clipped Indrapuram raster. Okay, so that we can give data underscore dir. I guess that's the name which we have provided. Data dir slash world of Puram underscore clip dot if. Okay, so we got that. Okay, so I'll just add a comment as well, like why we are doing it, so that it will be helpful for users who are seeing it. Then open the full so see guys, I'm giving all the things. Okay, studio.open studio as a source out. Now a check, like if AOI and raster share same CRS. If not, we project it. If AOI dot CRS is not equal to CRS, then AI to AI store will be keeping it into new thing, source into CRS, else keep it to same. Equal to, okay. After that check, what we'll be doing will then the mask will be requiring the list of geometries. So let's add the geometries over there. Okay, so we'll write geometry AOI raster geometry location and 0. Okay, then perform clipping. So out image will be a pixel array inside the AOI. Okay, so out underscore image transform is equal to mask.com. It is taking by its own, so you have the time. So update metadata. Now metadata for clipped raster dimensions. Okay, so guys, plus I want one thing from you guys, like please comment down if you think I can change something on this particular video. So I want you can speak out those things, so that that will be also helpful for me to check all the things like what I can do. Okay, so I believe that that will be helpful for me to get update, I think, what I can do extra or I can do better on my videos. Okay, so output meta is equal to source meta dot copy output meta dot update is equal, then inside that we'll have, okay, it is taking by its own, that will be 2. and then just got to transform or transform. Okay, so it did things all. Now so we'll be saving that to the clip. I have directly copied raster dot open clip raster. Clip raster is this one. Out meta has a destination type. Okay, confirm the file. Right, if the file got printed, I'll see. Okay, and this is print, or let's say write confirm the file. So print clip raster. Okay, so let's start it. Okay, it clipped very quickly. That's good. Now the rest others thing will be now I'll move to the next. Okay, now quickly down sample the preview for the optional, or it is optional thing, but let's do it now. Why will not do it? Let's do it. Okay, result. So as we got a crashing, so we want a quick visual of it. Let's add it. Okay, so for that the code which is there is from stereo dot stereo. Wait guys, so what we'll do is we'll be using the resampling method for the safe downscaling the preview thing. Okay, so from rastereo.enums import the resampling thing, and then after that we'll be raster.open clip raster, which we have already as a source, then downsample, then okay, so then what we can do is inside it will be rasterio.open, will be opening the raster and then defining the target. Okay, for target defining we need to be okay, so define target preview size. Let's take 400 by 400. Yeah, so preview height and preview width, right? Preview width and preview height will be this one. I don't know how it is taking this or how it is reading this. Okay, might be this is the same code which might be someone has done or something already there. Yeah, add that. Okay, read only. So we'll be reading the first band of it. Okay, moving on, no RAM crash. Okay, so data is equal to source dot read, that will be 1 out underscore share equal to h w and then these and two. These samples should be linear or bilinear. Resampling dot. Let's try with the bilinear thing. Linear or bilinear? Bilinear. Source data 1 outside is equal to preview height, width, and this thing. Okay, now we'll be plotting it. Plotting that. So plotting it will be plot. We have already the code, right? So let me write that plot code. Plot dot figure size 10. No, I'll not take 10. 6 by 6. Plot dot so data, so data stream map equal to let's see. Here we where it is. So this you can check it, guys, like at your end, like which CMap you can use. So plot dot. I have written already. Why it is not taking that thing? It is. Let's see. Okay. Hmm. I know that it was like giving. I was thinking something was off. Okay. Oh, good game. Good game. Good game. But what is this? Okay, might be some chunks of files which it has provided. Okay, no worries. So what we did is we asked Rasterio to resample the raster to a much smaller grid of 400 by 400. This uses a minimal memory. We can try something big. 800 by 800 to see. Okay, it is giving the same. Okay, let's give that only. And no, this same answers. Okay, so we have a visual of like we have some density type of thing over here. Now reproject to projected CRS. Okay. So guys, why I'm doing this? Can you type it in the comments? Tell me. So basically, I have already written reproject the AI to projected CRS, projected coordinate system. Okay, so that's why we need to be doing to create in meters, like 501 kilometer cells. We need a what we need a projected CRS system. So we'll be using EPSG 43857 for our convenience. Okay, let's code it. So we already have. So okay, let's write. I'm writing for the safe time. Yes. So let's UI projector UI projector equal to Okay, we got the polygon. Then so after this step you can now say like make a grid of 500-meter by 500-meter cells, 500 kilometer, whatever you can, 10 kilometer by 10 kilometer or whatever on the real world size, right? We have projected that. Okay. Okay, now the next step will be create a fishnet over Indrapuram. So guys, anyone of you knows what is a fishnet grid in GIS? If yes, write in the comment section yes. If no, then I'll explain in the next in this video. But currently, go and type it. So guys, to define what is a fishnet is I'll give a simple analogy to you. Let's take a chessboard, okay, and put it on the map. So why I'm giving the chessboard thing is chessboard has a grid system, right? It is equally divided. Boxes are there, so equally squares, let's say. So when you place that in your area of interest, it will be providing you a chunks of boxes. When you merge that, you will get a chunks of things. So basically the simple definition of fishnet is a fishnet grid is a network of equally sized squares or let's say rectangles that cover your area of interest just like a fishing net spread over a ground. Okay, so why we do this fishnet grid system in GIS? So as to break a large area into small area of manageable pieces. Instead of doing for the whole city, we divide it into small chunks. Okay, every grid should be having the same size and so that if you perform this on spatial analysis, let's say for population, which we are doing population per grid cell, crime hotspots, population pollution levels, as currently Delhi or Punjab, Haryana, all these pollutions levels are high. You can do this project as well as pollution level uh, things. Okay, so if you get the data, you can do it, right? So I'll also try to do this um, pollution levels mapping in our this Python project. I'll try to do that and I'll publish it as well. Yeah, the flood risk, tree densities, or traffic intensities, mainly the heat maps. It shows a better thing. Okay, so yeah, so this is what fishnet is basically for. And now from fishnet on this thing we'll get each grid cell will be one analysis unit for our population. Okay, why so this should be our text. Now let's start with the code. I already have the code with me. Okay, so let's create a function first. Create a function that builds. So I'm copy pasting the whole code for now because I already have that. Okay, then I'll be explaining what I have done in that. Okay, is that good for you? Let me know, guys. Okay, So this is the thing. Now I'll be explaining one each by each. So this is the function which we have. Then min x min y max x max y is equal to ai ay. So it will be basically what we are doing is we are doing it for exporting or let's say extracting bounding box. Okay, from ai polygon in meters. Okay, so create coordinate sequencings. Stepping cells size matters at a time, so that's why we have done these things. Then build square size grid cells. So this is for build grid cells. So cells for x and y, uh, cells append will be this. So you can use this code directly. Convert the list of shape to geodata frame. Geodata frame cells CRS is equal to AI. How the intersection we are using, return to clip. Okay, then create the size. It is already the cell size is 500. Grid projection we are doing. Create and basically that's I think number count first is one x. Okay, let's run this. Let's see. Okay, so from here will be what we'll get is okay. So total bounds we got the total bounding box. We step in increment cell size overlay will be how we are doing it. So we have now 500-meter grid converting by Indrapuram. Each cells will soon have the population count plus density. Okay, now we'll be reprojecting the grid raster to raster CRS. Zonal starts. Okay, now the text. Okay, okay. So what we'll do again now is okay. We project the grid Yes. So what we'll do will be open create raster. I'm also thinking raster and check it. Okay. So for that the code will be with stereo dot create raster. The next will be reprojected to match with raster CRS. Okay, why we are needing that? For donations. Okay, so we'll be writing yes. Okay. Okay, let's see. Okay. Now we'll be getting the zonal statistics, population per cell. Why? So why will be this? This is the we insert the 500 date cell. Okay. Hmm. Okay. So I have already the code. Let me add it. Think clean. Okay. We have the raster. Okay, so what we are doing, why we are doing it will be, so let's say we have changed that to raster clip, the same raster clip thing. Okay, or maybe we can keep that same, that will not be a worry. So then perform zonal statistics. Is performing the zonal statistics with sum plus mean on each grid cell. Okay, so this is to define you, this is polygons, the raster file. Statistics. This is to ignore the, okay, so grid raster is equal to CRS pop sum population sum, yes, is equal to stats, stats, what it, yeah. Let's see. Okay, population sum and population mean, we got it. Okay, okay, well, so we can see that what our grid cells align perfectly with the program clip what population raster. We can open it in CRS and reproject it into the CRS system. Okay. So we got to know now that sum will be population, sum will be the total population in that cell, and average mean will be, let's say, average per pixel value. Okay, so each cell now has real population numbers attached, so which we have converted into raw raster into human readable zones now. Okay, so this is how we have converted the value from raster value to human readable values. Okay, now we'll be computing the area population density. So why we are doing it, like, because the density per kilometer, okay, that is the population per, or let's say population per kilometer, that will be a powerful indicator for how much people resides or how much crowded that area is. Okay, so now to compute this thing, why we are doing it, as I said, besides the code will be, I have already had this course already because I have already performed this thing. So grid attribute. Okay, so we are doing this because let me write it over there. Okay, to switch grid CRS back to projected meter CRS and to calculate the area. Okay, so that's basically this. Switch Okay. Mhm. Give me a time. Okay, let's check it out. Okay, area is also defined because the grid cells will be same. Okay, the next will be creating a choropath map. Okay, uh, okay, let's create it. So we'll see the map over here now. I'll plot the map. Okay, color schema. Disk. Okay, so this will be having plot population grid cells, body output directory. I guess what we have is output dir, right? So that will be saved over there. Think, let's run it. Okay. Package schema word in the error. Let's see like why. Instead of a map classifier need to be added. So, so basically classifier we have not installed, I guess. Okay, it was installed, I guess. Okay, don't know. Let's see. I think executing is executing. Yeah, we got it. Okay, so coloring by population, we can see that how the population is here. Okay. Okay, so you know that means how it is distributed over the cells. We can get the populations over here. Now let's make is another thing what I think we can create. We have added that as well. So let's so it is basically converting our grid to a web display. So let's run this. Okay, thus and now we'll get the summary stats and I'll explain you what is the summary stat. So guys, one change which we had done because while we are getting the journal stats was we have kept this 0, no data was 0, but I checked in world populations, no data value should be minus 999 because because if mean or mode sorry mean gets into the minus thing, then that is not good. So what I did is I kept this value and then the population changes, then we'll recalculate it and we got this Indrapuram population per 500-meter grid. So according to this map, what is our analysis? I have written it down. So let's see. So we have dark red areas, which is 6064 per 500-meter grid means that particular grid value. So it is population is like analysis of the above map. So map shows the total number of people living in each cell grid. Population is equal to the absolute population, absolute people count. So let me add it into another. So is equal to absolute, then the analysis of the map is population per 500 meter grid is equal to absolute population. So what this map shows is, like, if you'll see, so the total number of people living inside each grid cell regardless the area. Color meaning the dark red is 6,000 to 8,700, you can see. uh, then the medium red, then the orange, and the yellow and cream. So the key observations is like the central and northwestern Indrapuram have the highest populations. These areas hold 7,000 to 8,700 people per 500-meter block, showing high occupancy per building, dense apartment clusters, popular residential pockets. Okay, so this is how you can analyze the population density and then put high analysis. You can do advanced analysis on these things. So then some grid cells with medium population still shows high density. This happens when a shell of has few buildings, but each is very crowded. Lots of mid-size apartments packed into small areas. Then the sparse population will be parks, playground, empty lots, commercial complex, and the main roads. Okay. Then this is the grid which we have put. Okay. So basically this is the Indrapuram area, if you'll see. Okay. So if you'll see here, the density and the calculation of population has been there. So let's say we have, so where I was before living was the Nitikhand part. So here, so you can see, right, the population density which we are grabbing on this particular cell is 6644. Okay, so the density is also high, so we'll also check the density. So sorry guys, so this map will be highlight the areas that are crowded, not just the high population. Okay, so we get this map through this particular code. So if you see Indrapuram population density hotspots, people per kilometer. Okay, so the analysis that done on this particular map, it shows that density is equal to pressure uh, on a area, that is basically the crowding. Okay, so what this map shows, this map shows the highlight tight people are packed into each particular cell. Then if you'll see that the dark teal, that is around 2,000 to 38,000 per square kilometer. Okay, this dark teal areas, these are the areas, right? And these are the areas which I was also showing in the above. If you'll see that, okay, uh, this one, it's 23,000, right? So it has the higher value on this thing, uh, on this particular part as well. So these are the color combinations and the density that has been added over here. And the key observations will be northern Indrapuram is the densest area zone, and very little open space, many multi-storied apartments. So this is the analysis that I have done based on the density key factors. So high occupancy residential, as it is Indrapuram is a town, so it is basically a urban thing. So how I got to know that it is a multi-storied or everything, I also know that, means I do also know Indrapuram area, so that's why I can make the ground truthing same. So which is also you can say that actual data which this particular analysis has been provided. So Cipra Sun City is a society over there which has the dense pockets, Gyankhand parts, Nitikhand also these are the high occupants. These are small packets where many people is living. So similarly, some central pockets are surprising sparse white and light patches in the middle indicates like parks, open ground, commercial building, road intersections, under construction and institutional areas. Density drops towards southern is from south to southeast zones. It is like more open plots, wider roads, low rise housing or something like that. And the summary table that we got, that if you'll see the mean is 4075, like at least the counts cells are like around 195 cells which we have, or the grid that we have taken, and in that mean is 4075. Standard median is I think 216, mean is 11, 25% is 23, 50% is 4270, 75% maximum is 8711 in a particular grid. Okay, so the most top populated cells is 60, 63. This is the grid number, and then the population sum and the density. Okay, that you can save it in. And the analysis which we done on this particular data. Okay, so that also I have added it. So let's begin with our analysis. So the study area, that is Indrapuram, Ghaziabad, was divided into 195 grid cells, each measuring 500 meter by 500 meter, the cell area which we have taken. So this is the cell area, you can see. Let me just zoom out a bit. So this is the scale area. So it is a bit covering the Khaga area, sector 62, 63. But yeah, we can clip the Indrapuram area, and this is basically the grid which I look into. And yes, so the key statistics what they tell us is count is 195, number of grid cells in Indrapuram is covered by, not Indrapuram, I'll say Indrapuram plus the nearby areas like 500 meter by 500 grid. Let's say that comes with the sector 62, 63, all those things. Mean people, the average population per grid is coming around 4075. Then the standard is variation in population, high density variation. Some cells are far more populated, that is 2166. Minimum is 11 people. Least 25% is 2340. Low density quartile, like you can say that 2000 people are living in 25% of those grids. 50%, that is the median, you can say 4240. 75% is 5634. Then the max number, as I say, 8711. So that is the count which you will get over here. So that is what I have interpreted out. So what this means in simple words, most of the Indrapuram is moderately highly populated with 4000 to 5500 people per 500 meter block. So this is a strong density contrast. Some cells have few dozens of people like parks and roads, while dense apartment clusters around 7000 to 8700 peoples. So this confirms Indrapuram is a high density residential node for or node of NCR. Okay, so that's why there are a lot of things we can calculate from it. Means let's say um, the areas where we can put the store locations. Let's say the area where we can build what we can build the stores, we can build malls, we can build shops, and we can build hospital, we can build ATMs, all those things which needed for population. Okay, those we can build on these things. So 10 most populated cells like 60, 63, 59, you can identify those areas. After identifying those areas, so what I got to know, like these cells represent the densest part in the Indrapuram high-rise apartment clusters, compact multi-storied housing, areas with minimum open space. Classic, it's a classic case of high NCR, high density urban morphology. Okay, so some examples will be Mumbai suburbs and South Delhi colonies, Gurgaon apartment belts, all those things. Urban planning meaning over here will be infrastructure demand zones. Okay, high service pressure shells like water, electricity, waste. So when you build a particular township area, or you can say a particular town, all these factors needed, man, means. And after in going into the future, you also need like what things needed on this particular area, so that we can avail those services to the public and they can use that. So that you can say that if a particular area has a demand, if we in a nearby area where the demand is less, if we build something good over there, a township over there, then some people might transfer to there, so that the uh, area will not be much congested after on that particular you can say specific area, right? So this is what potential congestion hotspots are. There areas suitable for target mobility planning, zones where social amenities may need reinforcement. Okay, so now combining both maps, what analysis I got will be like high population plus high density, severe pressure zone. Okay, high population plus moderate density, it is balanced apartment zones. Low population, high density, few buildings but extremely crowded. Low population plus low density, open areas, park and commercial roads. So this is the basic analysis what we can get from the two maps. So analysis about Indrapuram's urban structure. So this is the basic analysis which can provide. So what this means about Indrapuram urban structure is a classic high density township. Most population clusters is around 4,000 to 6,000 per 500-meter cell. Residential blocks are extremely compact, high population and high density multiple cells, very little open space in some mid-northern parts. Urban planning pressure is high in hotspot cells, water supply demand, waste generations, mobility congestion, public safety loads, green space deficits. Some southern and central pockets shows opportunity zones for cloud support, new infrastructure, more open space, lower population footprints. And the final summary what we can provide to you guys, and this is how you can build your summaries as well. In Indrapuram, population per 500 meter grid ranges from as low as 11 people to high as 8,700 people per cell. When we convert this to density, the hotspot region crosses 30,000 to 38,000 per square mil people per square kilometer, indicating extremely compact urban settlements. The densest region appear in the northwest and central sectors, areas dominated by multi-storied apartments. Meanwhile, the lighter zone level civil parks, commercial pockets, and open spaces. Together, these maps help planners to identify which areas where the services and infrastructure need to be strengthened, where population pressure is highest, and which area can be used as a support for future growth. So this is what we have developed from this project, guys. So it's a now 2 hour plus video, but yeah, I think it is fruitful that we have come to a conclusion of a area, like how we can be creating a project on this population density mapping. So I think this is a very good case. If you will go through whole project, you will be getting the whole analysis. So what I believe, I'll be putting this into the GitHub and all the analysis and all those things what we have done. And you can also do it for your areas, for whole India, I guess, if you have the good system and everything. But what I'll guess is, please do one support to me, like you subscribe to this video and like this video as well as the summarized video which I'll be publishing, where the GitHub link and everything will be there, where you can check it and you can also create a portfolio from it. But I need support from you guys, so please like, share, subscribe to Native GIS. And yeah, let's build more and more projects. Okay, that's all. Bye bye, take care. Workflows. Thanks for watching. If you found this video helpful, give it a thumbs up, subscribe to the channel, and hit the bell icon to stay updated on the latest in AI and GIS. See you in the next video.